following podcast is for informational purposes only. The contents of this podcast do not constitute tax, legal, or investment advice. Take responsibility for your own decisions, consult with the proper professionals, and do your own research.
This research in large part was about, okay, how can we start to add some more qualitative information onto the graph?
GRTiQ podcast.
We are like astronauts floating in the space of time.
Welcome to the GRTiQ podcast. Today I'm speaking with Rob Haisfield and Joelle Chen. I recorded this interview with Rob and Joelle to shine a light on their research, which was funded by a grant from the Graph Foundation, and to show, once again, how the graph ecosystem is exploring the edges of technology. And as you're about to hear, in this particular case, the edge being explored is at the intersection where technology, user experience, and knowledge converge. Much of what we discussed during this interview revolves around what's known as tools for thought. Although this topic is fairly academic, the essence of the concept is the study for how humans learn and synthesize knowledge through the tools they use. And the discipline goes one step further, to analyze the ways in which the tools we use actually shape our ability to think and synthesize. Almost to say that our capacity for thinking and knowledge is bound in many ways by the tools we use during the process. Using the paradigms associated with tools of thought enables technologists creating products with the intent of increasing knowledge or to produce synthesis to ensure that the design and features of the product facilitate such an outcome. To begin this interview, I asked Rob and Joelle to introduce themselves and provide a little background.
I'm Rob Haisfield. I am a independent consultant specializing in behavioral product strategy. So that's basically like, how do you apply behavioral science to product design such that you influence user behavior, such that it aligns with user and product goals? And then after a while, after like 2.5 years or so of that, I was reached out to by Yaniv, and we started talking about how we could get my research funded. And, up until that point, I had been, in order to manage my consulting, I had been working with tools for thought. I had to manage like multiple projects at once, 3 to 5 projects at once. And these hypertext oriented note-taking apps were incredibly helpful for me in order to do that. And it sort of started like this whole trend towards understanding that the software we use to externalize our thoughts is also a medium through which we can think and how we can think better. So Yaniv reached out to me to see if there might be some interaction between that and the graph ecosystem, and that ended up resulting in our research grant.
And Joelle Chen, I want to welcome you as well. Similar to Rob there, I want to allow you to introduce yourself and tell us a little bit about what you've been doing.
Glad to be here. Thanks for convening us. So my name is Joelle Chen. I am currently an assistant professor at the University of Maryland. I am in the College of Information Studies, also known as the I School, which basically gathers a motley crew of people from across different disciplines who are thinking about how people, information, and technology interact in various ways. What brings me to the I School is my interest in designing systems, very broadly construed, that enable people to do creative knowledge work. That's a little bit abstract. I ground that by sort of studying 2 domains in particular. So I think a lot about how to support designers to get inspiration, come up with new ideas, collaborate. And also I think a lot about scientists. How do they develop hypotheses? How do they synthesize literature? How do they develop theories, share their knowledge with each other, that sort of thing. So I've done things like designed and developed and tested alternative forms of search engines for scientific literature, search engines for designers to search for inspiration in biology textbooks. And recently, and this is where Rob and I have intersected, tools for scientists to manage the huge load of scientific literature that they need to synthesize in order to make progress, both alone and together in teams and also in a distributed way. So in that sense, the reason why I'm doing this in high school that's really appropriate is it kind of cuts across all levels. So what Rob was talking about in terms of tools for thought is like what the tools that we use on the sort of ground level, like, and the day to day, but that has implications or is interacting with infrastructure level things. Like, how is it that we index knowledge in the first place? How do we share things? Why do we choose to put stuff in journal? Why do we have the metadata that we do? Why does the search engine care about people and journal names and things like that? Is that good for sharing knowledge? Those are the kinds of questions that I ask. And what I want to do is to, if I don't like what I see, figure out how to design something different. So that's where I am right now. My roots are in cognitive science. So I have a long history of thinking about how is it that creative knowledge work gets done in a cognitive system, which includes not just what's inside my skull, but also what's the system between myself and my tools, and also cognitive systems that are formed in a group, like myself and my collaborators and things like that. So that's kind of my path into this space, and it runs through human-computer interaction. I spent 4 years in the HCI Institute developing tools and dabbling with applied machine learning, things like that. So that's what brings me to this space.
Well, we're going to have a lot of fun today and explore a lot of important topics. And before we really get started on some of these themes, why don't we also set some context for how you and Rob came to know each other? So I don't know which one of you wants to take the lead here, but what's the story of you two meeting?
I can tell the story from my perspective. Honestly, Rome research is, so when I was saying that during my consulting, I needed to use these hypertext-oriented tools in order to properly manage my thoughts across projects. Rome Research was the one that I really started with that felt like it went beyond the purview of just like a standard note-taking app. And at the time, it was like one of the first that really took that leap towards hypertext-oriented organization and block-based structures. And Joel and I both use Rome Research in order to manage our thoughts. We both first started using Rome around the same time in 2019, late 2019. And at the time, it was one of the first note-taking apps that felt like it went beyond the purview of a standard note-taking app into this point where it became like a tool for thought. Right. And so the early community was very active in the Slack channel that we had. And so, Joel and I talked a lot because Joel is, as he mentioned, he has his background in cognitive science, and my work is in behavioral science and applying that to product design. So I've kind of thought of myself as not like I'm academia adjacent, if not in academia. And so eventually I started doing these interviews on my YouTube channel where I would talk to people who used Rome Research in impressive ways. And Joel was one of the first people I thought to reach out to just because we had been chatting in the Slack channel so much. And I saw how insightful he was. I saw how thoughtful in his approach he was. And then turns out he researches tools for thought and how to think better within them. So it was a very natural fit. Did I cover it well, Joel?
Yeah, that's what I was going to say. I think I recall some messages from you on Slack, such that when we ran into each other in like a call with some users of Rome Research, I recognized your name. And, I think you had some. You're always you're a skeptical person. I really appreciate that about you. And I think the message that you had on Slack was really constructively skeptical of something. You were critiquing some kind of feature. I don't remember what it was, but I think that's what stood out in my memory. And so then, like you said, you were the first. I think I was the first one, right? That actually went live on the Rome tours. Yeah, so that's where we've met and intersected, and we both have deep interest in what is this thing that we're using? People are excited about it. Is it really new? what can it do? What are its limits? We always nerd out about these things, and we like trade like, hey, did you see this tool? Did you see this like cool thing that this person is doing? And I just really appreciate his insights. And we've been collaborating for a long time, way before we started this like formal research project. And so when we did, I was like, hey, do you want to work this together? Okay, yeah, sure. We've been doing this for a long time.
Yeah, I mean, Joel and I, one thing I just want to point out is that our graphs look very similar to each other, and that was like one of the things that stuck out to me the most when I saw how he uses Roam, is that, like you can tell a lot about how a person thinks by just like the general structure of what they put in there. And if you like look at our graphs, they look very, the shapes are similar in how chaotic they are. So I just, we were looking for an excuse to work together on an actual project, I think. So the research grant was a great opportunity.
So I've thought about all the different ways we could enter into, a great dialogue here for listeners to better understand some of the different research threads and contributions you're making. And I think we start with Roam research because that's a great convergence point for how you two met, but it's also one of these tools for thought that seems to come up quite a bit in terms of some of your collaborations. So let's frame this. What is Roam research, and why is this a better tool than some of the tools that users might be familiar with, from just note-taking with a pen and a piece of paper all the way to something like Evernote or OneNote? So what is Roam research, and why is it so great?
So first of all, the roots of Roam research are what drew me to it, where Evernote and Google Docs and OneNote, all these different kind of note-taking tools are properly in the note-taking category. They're all about, capturing things and filing them away into folders and sort of searching over them. Roam research caught my eye because they have a white paper that sort of set the vision for what they were trying to do, which is to build a new infrastructure for representing and sharing knowledge in such a way that we can increase collective intelligence. And so they drew their roots back to some of the early thinkers in the space of tools for thought, like Vannevar Bush and Doug Engelbart and Ted Nelson, right? So the fact that they drew their roots back to that is what drew me to Roam, in terms of they are setting their sights higher than simply helping people to manage their personal information, which is important but different as a goal from like, how do we help people to do research, right? And that's where the research comes in. And so they have this bet that rather than storing information as narrative prose in different documents that you put into folders that maybe you can tag, they put all their bets in on this data structure of information as a graph. And a lot of the value of the information, the semantics, is not just in the individual notes, but in the relationships between the notes. And so that's where the term hypertext comes from, where it really emphasizes connecting different units of information. The other distinguishing factor is this, I think Rob mentioned, block-based structure, where in a similar fashion to some of these outliners like Workflowy and DynaList, the unit that you can search for and operate on and link is much more granular than an entire document, right? So if you think about like an outline, every single bullet is a unit of information that's complete in itself, that's linkable to other things. So it allows you to do things like, when I reference a paper or an essay that Rob wrote, I can reference a particular paragraph or a sentence and remix it, or use it for something else, or connect it to a thread of ideas. So that has its deep roots in kind of the work of Ted Nelson. I think the data structure is called zippered lists. And so this, I think it was the 50s, somewhere around there, like somewhere between the 50s and 70s was when these early thoughts about hypertext came to be. And so Roam research is like deeply grounded in those ideas of, let's think differently about the information architecture of how we can support a particular kind of thinking that requires you to connect ideas across different domains and different categories. It's not geared for efficiency and neatness. There's a reason why, Rob mentioned chaos. It looks like chaos. but the meaning emerges and is sort of like contained in the relationships between the nodes. So some people there's a natural connection to the graph because the underlying data structure is a graph of knowledge.
When you think about like other applications too that emerge after Rome, like for example, Obsidian. Now, Obsidian is currently like my main driver. It's the main tool that I use. I use a few project-specific Rome graphs, but I mainly use Obsidian at this point. And there was a point in time where I very actively thought to myself, okay, I'm going to switch from Rome to Obsidian and just give it my best shot. Like, and switching was not easy, but like one of the things that I realized was that Obsidian had enough features that I was able to reproduce almost every single one of my workflows from Rome. However, and this is what I'm getting at too when I talk about how, the design of a product can influence how people use it. And then therefore the design of a tool for thought influences how people think within it. Rome, I think, was much better suited to help me develop those workflows in the first place. Whereas in Obsidian, despite the fact that I could replicate those workflows, I don't think that its design was really prompting me towards that. I think that it's a lot more neutral in its design. It's a lot less opinionated. And therefore, like that's just like the sort of thing that I'm thinking about when I'm trying to say, which like the overall goal of our research project was, how do we design these software tools to help people think better? Particularly, how do we help them achieve synthesis, like intellectual creative synthesis? So we were really exploring these design factors and functionalities that would prompt interesting thinking styles.
So, Joel, I wanted to start with Rome research because it is kind of the thing behind most of what we're going to talk about in a concrete way. It's a note-taking software that allows you to do a lot of different things structurally. But I guess my question here is, a lot of listeners aren't going to be aware of the fact that this type of thinking even matters because they just go to the App Store or they buy a notebook and they pay no attention to the fact that the mechanism lends itself to the type of thinking they can do. As a discipline, what's the history here? When did we start thinking about these types of issues?
Oh, that's a wonderful question. That is a wonderful question. There's a lot of different threads. In some ways, you can trace this back to medieval times. There's like histories of the amazingly sophisticated structures that people put into paper and pencil. Tables and different diagrams and all these different information structures in order to support particular kinds of thinking. Like I want to develop new ideas, or I want to classify all these organisms and think about how they relate to each other so I can understand the structure of life or whatever. So that's like one sort of practice thread. So for as long as people have been thinking, leading thinkers have been trying to innovate on how do I think in particular mediums, right? How do I change the way that I represent my thinking or draw my diagrams or whatever? So that's one thread, and that's as old as thought itself. In the Renaissance era, there was a practice called Commonplace Notebooks that was very widespread, where people would sort of keep all these clippings and they would organize them in a chronological way, and they would sort of juxtapose a lot of different things. And so that was a design pattern also. And that's also kind of the thread. I would say the current crop probably traces back to the dawn of the computing era. Like people started thinking about, hey, we have a completely new medium where we can store information and work with it that's different from our files and our folders and our books. What do we do with that? How should we structure it? And so that's, I think, where the roots of Rome research go back to most strongly. And so you can talk about that as like new media, human-computer interaction, personal computing. Those things kind of converge. And they're sort of distinct from library information science that for a while has been thinking a lot about how do we efficiently retrieve things, how do we classify things. And that I think is not quite as connected to the roots of Rome research. So that's where all kind of traces back to the present. And there's a good essay that I like to recommend in terms of the thinking around this idea of tools for thought by Andy Matushak and Michael Nielsen. And it's called very helpfully, How Can We Build Transformative Tools for Thought, that traces this lineage back to the old days where, a tool for thought, a new medium would be like notation for calculus, for example, right? We had to invent a new medium for thinking. So that's kind of where I place the lineage of these ideas.
So, Rob, a natural question then when we start talking about tools for thought and the different approaches to this field is, what type of thought are we trying to foster here? What type of knowledge are we going after?
Yeah, so I would say that we're really curious about fostering synthesis, really. So how can we enable people to recognize the connections between subjects and come up with like a greater conceptual whole that sort of encompasses everything? In my background, I studied behavioral economics in college, and then which is itself a synthesis between behavioral science and psychology, right? And so like one of the thought experiments that I really like is, imagine that we have the 2008 financial crisis and behavioral economics had not yet been invented. How could we create a global knowledge graph that psychologists and economists participating in this just sort of recognize the connection and create behavioral economics? How can we create more of these behavioral economics, like more of these domains being spawned by people realizing that they're talking about the same thing as other people in a different field, just using different words, like in my own work. And this can apply on the individual level as well, right? So it's like, prior to my job at EdgeNode, I was consulting in behavioral product strategy and gamification. And one of the big things that I noticed is that behavioral scientists and game designers are asking the same questions. They're just asking them in different language. Like, how can we design this game such that players have the most fun in it? Because how much fun they have is going to depend on how they're playing the game. And the game designer happens to control the entire environment through which people interface, So it's like behavioral designers are asking the exact same questions. It's just different language and with different methodologies for studying those questions. So I really just want these tools for thought to be able to support that sort of reasoning.
And so, Joel, there's two levels to this, right? There's synthesis for the individual, and then there's synthesis for multiple individuals. So how does that factor into this? How do you leverage to a broader group?
Yeah, that's a really good question. So I want to first riff on Rob's point about this idea of pulling things together into a conceptual whole. And I wonder about a foothold might be, I think most people have a sense of you play Cluedo and these kind of intelligence analysis kind of games, and you're trying to figure out who did it. And you got a bunch of clues, right? And you're putting them together into an overall theory of what happened, and then use that to predict who was the person that did the crime, right? That's sense making. Where I came from was synthesis is a thing that scientists need to do all the time when they do a literature review, not to summarize what was done, but to understand the state of play. What do we know? What do we don't know? How does it all fit together? And then decide we need to do this experiment next. Or Darwin's theory of evolution is a wonderful example of synthesis, where all these observations by themselves about these finch beaks and, how people change and so on. And he puts this all together in this overall theory about this is why diversity happens in species, right? That's the kind of thing that I really want to foster more. And often it happens in one mind. And your question is very insightful because it's getting harder and harder to do that, right? So think about a very recent salient example of pandemic response, right? How do we deal with the spread of the virus? You may think that that's a simple matter of public health, but it's not. You have public health, you have virology, You have physics, right? This kind of spread of aerosols. You have obviously behavioral science. You have sociology, right? You need to pull all these things together into an integrated whole to come up with a strategy for what you do, right? Francis Collins from the NIH, he was interviewed and he said, we probably should have thought a little bit more about how people were going to respond to messaging about vaccine. That's like, to me, an example of not synthesis, right? And where we want these, just like Rob is saying, these game designers and behavioral scientists, these biologists and public health people, they need to talk together. They need to synthesize across these different minds into an integrated whole. And that's really hard. And that's the reason why I think your question is super insightful also is that is the thing that we discovered in our research is the most hard to do. Lots of people have figured out ways to do synthesis in one mind, but very few people have figured out how we're going to do this across multiple people, which is increasingly necessary because it's just taking too much time for any single person to learn all the different fields that you do in order to solve like hard problems. So to me, the end goal of the state of knowledge is the same, but it's just a hard mode. It's much harder to accomplish when it's distributed across multiple minds.
I want to point out one specific thing that Joel said that is very important is that strategy is synthesis. So it's not just a matter of how do we get more interesting areas of academia. It's like if we want to actually solve the world's most important problems, we need synthesis. We need strategies to solve those problems because none of those problems that are actually difficult are going to be things that one single domain is going to be able to answer. We need synthesis.
The GRTiQ podcast is made possible by a generous grant from the Graph Foundation. The Graph Grants program provides support for protocol infrastructure, tooling, dApps, subgraphs, and community building efforts. Learn more at thegraph.foundation. That's thegraph.foundation.
Hi, this is GRTiQ. For well over a year now, the GRTiQ podcast has consistently taken listeners inside the graph and Web3 by shining a light on the people working to build it. Through their stories and their insights, we've not only come to learn or understand new things, but we've also come to appreciate the nature of work, the depth of passion, and the compelling human stories that are driving this revolution. In working to make my own contribution, I've had both the opportunity and responsibility to help share these stories. And through this experience, I've had the opportunity to meet many of you and form new friendships. And for that, I'm truly grateful. To all of you who've taken time to share an episode with a friend or on social media, to leave a review or rating on your favorite podcast platform, or simply reached out and expressed support of this podcast, I want to say thank you. Some years ago, I remember watching a 60 Minutes piece, and for listeners that don't know 60 Minutes, it's a news, interview, television show, and they were doing some expose on artificial intelligence and the fact that they could feed AI, a bunch of medical journals, for example, and the AI was able to synthesize this stuff more quickly than humans. How does AI fit into some of your thinking on this?
I think that ultimately most of the interesting synthesis is going to happen in human minds. There's just too much implicit knowledge that comes into play in figuring out the right answer to something that AI just is going to struggle with. I mean, partially because AI, a big part of how it works, or at least the probabilistic type of AI, which most people are used to hearing about with things like GPT-3 and DALL-E too, is, the probabilistic AI is going to be, it works based on its training. You have to set a goal for it to train against. And a lot of the synthesis is stuff that happens even without a goal. Like people just realize that a connection is there or that there's some interesting insight. Ultimately, things like DALL-E and GPT-3, they're leeching off the creativity that all of humanity has built. They're not necessarily creating their own. That being said, I think there are a lot of really important roles that AI can play. Like one, for example, is just that the larger your knowledge graph becomes, the more work that you need to do to be able to maintain it. Especially if you start bringing in structured data, like things like, for example, this paper, like if I have to just manually enter into my note-taking system, like, okay, this paper has this author, it was published in this year, this journal, these pages, all that. If I create like all of these columns kind of for me to manually fill in constantly, then I'm just not going to do it. Like the more structure that people pick up in their systems, the more effort it takes to maintain it. At the same time, structure is like one of the most important parts when you're considering the question of how do people think together. It's really hard for people to come together on unstructured thought. Right. So I think that AI can play a very important role in adding structure to unstructured information. Like one of the big things that we found in our research was that a lot of people just didn't want to be slowed down. Like when they were trying to lay out their expertise on an area, then, if they had to add structure constantly to that data, then that would slow them down from just writing out what the actual answer was. Right. And so that means that we need to be able to structure information after the point of intake. It can't just be like, it can't be something that you require of people while they're writing, because if you do, then that might lead them to lose their train of thought. So what can play that role? AI could play that role. It could start trying to like classify that information in hindsight for people. You could also have other people play that role. Maybe you don't need an AI. You just need thousands or millions of people that are reading over that data and adding more data in hindsight to it.
I'm glad Rob framed it in this way. I generally think about the roles of AI can be sort of classified into two broad categories. There's a framing of automation, which is we're going to do what humans do, but better, and we'll replace their work. That's the implication that I heard from the AI is going to read the literature for us. And then there's augmentation, which is the AI is going to do things that assist the human to do what they want to do faster or better. I'm pretty confident that the current crop of tools is insufficient for reading the literature for us. And there's two reasons for that. The first is just we don't really have a good handle on how these powerful tools do what they do. And it turns out that truthfulness is not one of their strong points, which is pretty important for making sense of scientific literature. Even that being said, when you look at the state of the art in terms of like being able to summarize scientific literature and extract information about what was the key result, who were the patients, what was the effect size, we're looking at accuracy rates somewhere between 68 to 80%, maybe. And so that's not nearly good enough for it to run on its own, especially if there's no way to understand what kind of errors it makes and to sort of have a systematic sense for that. You got to have a human in the loop. Just to give you a concrete example, during the COVID pandemic, when the literature had completely exploded, it was like ridiculously high increase in number of papers. The White House partnered with AI2, Allen's Paper Intelligence, artificial intelligence, to figure out like, can we do this? Can we build AI workflows to summarize literature for us? The winning solution was a AI workflow that initially classified some papers and then worked together with medical experts to synthesize the final sort of understanding of what happened. So that gives you a sense of where the state of the art is. The other reason is that the literature is actually pretty bad in terms of like structure for AI. There's a ton of tacit knowledge that's not in the writing that you just don't have. And machines we don't have a good way to give them a world model yet, let alone a general world model, common sense, let alone a world model for a particular domain of literature. That's what scientists have. They read this experiment, and they have a sense of where it was in the literature. They have a sense like, oh, Rob, when he says this, he means that, or like, this is what's unsaid. Literature, like any human communication, is incomplete, and humans fill in the blanks in ways that machines currently cannot. So that's my general stance in terms of like, AI is not going to save us from the kind of information flood. We got to figure out ways to enhance the way that we work together. And so to Rob's point, AI can assist, but you also can figure out smart ways for us to work together better to kind of collate our efforts, right? Because if you think about it, like one way to think about it is that the work of extracting information from papers happens every single day. Every scientist reads papers. They're already summarizing the key takeaways from papers, extracting the information. Where does that go? Nowhere. What if we could figure out ways for us to sort of like share this intermediate outputs with each other and collate them into a greater whole? That's a thought that excites me, that we want to explore. In that way, we can sort of be smarter together than we are by ourselves.
I wanna just pick up then there too. Like I think that Joel's framing of automation versus augmentation is like a really important one, right? And where I'm primarily coming at it from is just that ultimately user behavior is a big part of creating a semantic web. You can't get a semantic web without people structuring information in certain sorts of ways. And I think that AI can simplify the work for the user in a lot of points. Now, is it going to be able to create the synthesis for us? That's a tricky question. Like one thing to consider is that there are multiple types of AI. Like, for example, there's probabilistic AI, which is something that, like when it gives you an answer, it can't explain how it got to that answer. It's more just that it's probabilistically learned over like a very large data set that this is most likely to be the answer that you're searching for. Then there's also like logical AI, which is also known as good old fashioned AI, which is something that is really, it's just trying to encode the logical relationships between things. And when it has all of those, it can actually like make some pretty interesting inferences that traverse around that knowledge graph. So like when I'm thinking about it, I'm thinking like, hey, we can get users to make a very interesting knowledge graph, and where they're encoding a lot of these logical relationships for the AI, and maybe even we can get AI that can derive just from people like writing normally, maybe it can derive some of those logical relationships, and then it suggests those to users. Users confirm or deny them. And in the act of confirming and or denying them, they're also training it so it gets smarter, and then from there, it can do like a lot of interesting things. So like maybe if economists wrote like all of their scientific literature into a discourse graph that a logical AI is able to interpret, and also a psychologist, like all of the psychologists did that too, then maybe the AI could like tell people, hey, you two should be talking to each other because you're talking about the same thing in different language, because we just know that like the shape of the graph here is pretty similar between these two things. Like maybe it can do that. But like ultimately there's still like there's the human in the loop where we're providing the knowledge.
So I want to turn our attention now to the research you both did together. And Rob, at the outset, when you introduced yourself, you talked a little bit about Yaniv reaching out to you. Let's go back to that initial story there of context, why Yaniv reached out and kind of what the original conversation was. And then we'll move into what the research was and the question you were trying to answer.
Well, at the time, I had been pretty vocal about how I use different tools for thought and what I thought about them and what I thought about their design. I had a YouTube channel where I'd make videos about it and all of that. So like, and really, I just am a connoisseur of this space. I really try to explore it all and understand as much of like the landscape as I can. So, at one point after I had posted one of my more popular threads on the subject, he reached out to me and said, "Hey, can I support your research?" At first, I thought to myself, "What research? I just use these tools." Because like really, like that was a big part of why I had talked about this stuff, was because, like in my consulting agreements, I wasn't able to talk about these things publicly. Like I wasn't able to talk about my specific work publicly, but like I could talk about like the meta work of how I was doing it. So that's what I talked about. And eventually I realized, well, actually, I am doing research. It's just informal. And maybe I could make it more formal. And then in doing so, answer more interesting questions. Right. And I also knew like vaguely that Edge and Node was working on some sort of thing in the space of what Yaniv asked me to research. But I had no idea. Yaniv reached out to me about me doing research, and like I was just thinking about like, okay, how do I apply for this grant? Like, what am I asking for? And I realized that I needed Joel to work with me on it, because for me, one of the things I'm really good at is I'm good at this like sort of pathfinding. You know, like I'm a very good explorer of the space, and very good at like intuitively figuring out what are the most important questions to answer. What are some things we can accept as true and base further research on? But Joel, you know, like he's published more than 40 papers at this point, and many of them are on interesting ideas and how software can support better thinking. I knew that I needed his background to be able to support like and actually like ground my exploration in the prior art. So that's when I reached out to Joel. I was like, hey, are you looking for a new research subject? Because I've got one.
Joel, Rob reaches out to you. He proposes this research, and you eventually go to work on it. Talk to listeners about what this research was and the questions you were exploring.
I think the connection to the graph is very natural. To my understanding, one of the core things that the graph has been thinking about is how do we build infrastructure to enable people to share things, data, knowledge, apps, workflows through a different infrastructure than Web 2, sort of more decentralized, more peer-to-peer. That fits really nicely with what I've been trying to think about in terms of how do we get out of this mess of the literature being too big for any single person to grok. And to use an analogy, one of the things I've been thinking about is this idea of how do we make it easier for two minds or more to come together, right? Really quickly. Because like I said, as I said earlier, you know, teams and bring minds together takes a long time. It's very, very difficult. Requires a lot of face-to-face interaction, a lot of back and forth for a long period of time to kind of build your knowledge base together. And so really thinking about like the structures of knowledge exchange in a similar fashion to how, like, if we, you know, what we came up with the supply chain infrastructure for containers, we figured out that, you know, just use a single container. The ships can use the same thing. The trains can use the same thing. The trucks can use the same thing. That revolutionized our ability to sort of ship things to each other and revolutionize trade. I want to think about how do we do something similar for knowledge exchange to make it so that we can exchange knowledge a lot easier and bring our ideas together a lot easier. And so if you think about, like, if you have an infrastructure for exchanging knowledge, then we have to think about what the protocol is, right? What's the structure of the stuff that's going to be passed back and forth? How do we sort of like, okay, Rob, you're going to send me some stuff. What are you going to send me in a way that I can digest? This is where we keep coming back to this idea of structure, right? What does it look like? Is it a document with a bunch of unstructured text in it? That's what it is right now. It's actually worse than that. It's a PDF, which is completely not machine readable. It's a picture essentially. Or is it going to be structured as an ontology, where it's like a knowledge graph, where we have like proteins and relationships between them, sort of like download that into my database? Or is it something in between? Those are the questions we're exploring. And what would it take for people to create that structure? Because right now, the tools don't make it easy to do anything more sophisticated than writing a bunch of text, or maybe like slapping images on a canvas. Humans can see structure in that, but only if they share context, and machines can't. Right? Machines don't know anything about it, so machines can't help us. So that's where the AI comes in, as well as like this idea of structure is like, how do we make it easier for people to share knowledge with each other? How do we make it easier for AI to help with that process? And it's all about structure. What's the protocol? What's the schemas? of knowledge sharing. And so I've been thinking about that for a year-ish prior to Rob reaching out to me. And so I was like, oh, cool. There's another chance to sort of talk to more people and like figure out what's going on. Because I was really thinking about like, what's the bottleneck to, because I had a bet that there's a particular data structure, this discourse graph, that is useful. And the question is, how do we get that? And so what we wanted to do is talk to people in terms of what would it take to sort of integrate authoring tools into people's workflows to lower the barrier to people publishing this sort of thing alongside or in addition to or instead of unstructured narrative text as the medium of exchange.
Mm-hmm. Yeah. And I want to add to that, when he said the structures of knowledge exchange, right? Like we've got to think about, okay, how is knowledge exchanged between users, but also how is knowledge exchanged between the user and the computer, such that the user feels like they're communicating with the computer, such that later when they ask questions, it can answer. And to Joel's last point, where he was talking about how do we get something that's maybe a little bit better than just unstructured paragraphs in the document, there are different forms of information that are better for communication. Like you could say that the communication between users is supported by documents that have like paragraphs in order, like just people writing an essay, for example. But then you could say, okay, how do we help the computer understand it better? One way you could do that is through headings. You could say that like anything that's under under heading 1, like heading 1 is the parent, and then anything under a lower heading like heading 2 that's smaller, like that's nested within heading 1. Like you could say things like that would help the computer understand it better. You could say things like, okay, let's say people write into an outline, like just bullets that are indented underneath each other, and the computer would be able to understand an outline probably better than they could understand paragraphs in a document. Like this point I got from talking to a guy who goes by Flancian on the internet, who's building a tool called Agora, which is like a tool for thought that brings people's public notes together. Like one of the things he was just saying is that computers know how to parse an outline because they know how to parse trees, right? Like if they're looking at a tree, they know, okay, the information indented under a parent node is going to be related to it, because they know how to work with trees, right? So it's about the exchange between users, between the user and the computer, and also between users and themselves over time. They're all important.
So Joel, I want to ask you a question as somebody that was kind of introduced to this opportunity via Rob. When did you become aware of the graph and what it was working on, and what were some of your first impressions?
That's a fun question. The timeline is a little bit fuzzy, in part because I'm a relative newcomer to the Web3 space. I believe that I learned about the graph first through Protocol Labs. Protocol Labs built IPFS and Filecoin. That was my introduction to this whole idea of Web3, which is very different from, I think, the average person's introduction through crypto or NFTs or whatever. Like to me, it's about like building a different internet. And in that mix is the graph in terms of like infrastructures for how do we actually exchange information and store information. So that was the general space I knew about. And so like I asked Rob, but what's the interest in this? And like, oh yeah, the graph wants to know about like, how do we actually enable like impactful application on this new infrastructure? Is my understanding of the connection. I was like, that's great. Like this is awesome. My general, impression before all this like crypto stuff went down was like, this is great. Like I love, this new space of thinking about these key values of decentralization and kind of giving power back to the people and, more robust infrastructure for the internet. And so I'm very on board with all of those values and goals, which are still true. Just kind of sometimes gets overshadowed in public discourse. And so, yeah, I'm excited about that vision in general. And I'm a small piece of it, connected to a small piece of it in terms of like using the internet to exchange knowledge, but much richer than that. There's finance, there's, archives, there's, all kinds of other things. that are different from what I'm doing, but they share the general same ethos.
All right, so Joel, let's then talk about the outcome of the research. What were some of the findings that you and Rob discovered here?
Yeah. So I would say there's like two main categories of findings, right? So one is sort of, we can talk about it as descriptions of how things are right now, right? How are people working? What are the challenges? And second set of findings has to do with what does the design space in the future look like? What are some kinds of tools for thought or kinds of design patterns that are not mainstream yet, that are important to keep an eye on because they can expand our capacities and change the things that we don't like about what things are right now to closer to what we would like. So for the first set of findings, in terms of how things are right now, we started with this question. One question that guided our thinking was, what are the structures that people are already putting into their thinking and their externalizations and their notes that is currently only legible to them, but could in principle be translated into a format that's legible to other people? Are there conventions that people use? Are there like kinds of structures that we could sort of teach a computer to recognize? So that's what we were trying to figure out. And we saw a lot of structure, a lot of idiosyncrasy, but there was some consistency within people. Rob hinted at this a little bit. One of the major findings was that structure was this double-edged sword. Like, just to make this a bit more concrete, what we mean by structure, there's aspects of it, right? One of this is like, you make distinction between types of things in your notes. For example, some people will distinguish between this is a task and this is a project and this is a issue. When it comes to knowledge, you may say some people will distinguish between this is a question, this is a idea, this is a reference, right? Do people make these distinctions both conventionally in their heads, but also formally in some specified conventional way in the tools? So that's one example of structure. Another example of structure might be when people say this is related to that, do they just say that, or is there some trail that we can follow? Right. So in Rome, when you connect two things, there is a trail that we can follow. It's not a semantically meaningful trail by itself. It's just an edge. So something we're curious about also is like, do people specify the meaning of how things are related? And some people do, some people don't. What we found was that these structures are really important for the future when people want to reuse their own notes, to synthesize them and think about them at a higher level. Like, let me gather all of my ideas and line them up into how they kind of address this question and dig into the evidence behind them that support and oppose that, for example, things like that. You need these structural conventions, like as Rob said, to enable the machine to assist you. However, people make very deliberate choices to avoid specifying the structure. One reason is that you might think is true, and it is true, is that it's very annoying to put formal structure in. You got to stop and like tag things, or like, formally specify a title, put some kind of convention in current tools, right? So that's not necessarily always going to be the case, but in the majority of tools that we see today, adding structure that is legible to yourself in the future and to a machine is disruptive. So it's not just that people are lazy, because the other thing is that in the early stages of complex thinking, knowledge work, often you want things to be ambiguous. You want there to be multiple ways of thinking about things. You do not want to pin things down into a formal structure that may be incorrect. You may not want to classify things in a particular way. And so there's a deliberate choice to defer structure because it's helpful for thinking. That trade-off is a difficult one to overcome, because it's not just that people are lazy, is that there's the nature of work itself requires that you defer structure until later. However, in the current design of tools for thought, there isn't a good way to overcome this trade-off. And so the result is people really struggle to collaborate with other people because there aren't good ways for them to bring other people up to speed. They can talk about it, what they've learned, but they can't enable people to make sense of it and explore it, right? Because that's in a structure that's only legible to them. But maybe may not even be in their notes, may just be in their heads. There was another common theme we saw, their thinking was distributed across many tools. So the overall shape of the finding is not particularly new. There's decades of work in ATI that talk about this kind of trade-off of formality. But this idea of like the lack of structure being not just a reason of laziness or like annoyance, but also adaptive for thinking, put a finer point on that trade-off. We're going to need to deal with that question when we figure out how to add structure. We probably want to be very careful to avoid forcing people to structure, even though it's helpful later on. So Rob keeps mentioning this idea of like structuring in hindsight is an important design problem that we want to see people tackle. How do we enable people to structure in hindsight a lot better, or add structure in a non-destructive way? So that kind of segs into the second half of findings is like, well, how might tools look different such that this trade-off is able to be overcome? And we saw lots of really amazing design patterns. Most of them are on the website. And, there's like Rob mentioned this kind of logic-based sort of AIs that allow people to essentially define like the grammar of things and how they relate. And you can sort of then say, when I say a cookout, you can infer that there will be people there of type person, and there'll be items there of type food, and there's these relationships between them. And the structure is then added just by kind of defining that thing in a very natural way. And so like these kinds of like ways to tell the computer what concepts exist and to change the data structures is like, I think, a very powerful design pattern that we haven't seen a lot in tools, where, the kinds of things you can express in the tool are often very imposed upon you by the tool designer.
Yeah, so I just want to point out that Joel has, like, I was literally like outlining how I might answer this question. Joel independently came to like the first 3/4 of it. I guess what I would just add to this is that, yeah, so when we're talking about how tools can design themselves different, one takeaway is that many people have their own idiosyncratic styles for adding structure. And many times when they don't explicitly add structure, there is still some implicit structure from a consistent pattern of user behavior, right? So one of the things that that tools can do is they can design themselves such that the user can create rules that describe their styles. And then the tool can just pick up structure from that. And so like one of the ways to do that is to say like, okay, this logical AI is starting to pick up the relationships between things and go from there. Another big takeaway is that these tools for thought can have a domain specific language for thinking, right? So outlines as done in Rome are one format of that, which is that, indentation means that things are related to each other, and links to items indicate graph relationships. You can also do more. Like, for example, you could design a spreadsheet that is able to take cell adjacency as an input for different types of structure. You could say if it's to the right or left, that means one thing. If it's up or down, that means another thing. But the users can generally write into cells given a few sets of rules, and then the computer is going to be able to get structure from that. Well, not just the computer, but like other users too. Like this, again, this is also about how can users transfer information to each other with a high degree of information density. And one of those ways that you can do it is like, if we're trying to pick up implicit patterns in how users structure information, then one of the ways we can do that is through search. Through a good enough query language, we're able to describe very specific patterns in how users write. In Joel's work, he has a plugin for Rome Research called the Discourse Graph plugin. And one of the things that it does is it lets you define graph queries, through Datalog, which is a query language designed for logical relationships. He lets you describe graph queries that cover a pattern of prior user behavior. So these tools for thought can do that as well. Really, the big takeaways from what Joel was talking about, again, are, it's really a question of like, okay, how can you get people to share context with the computer or with people? One of the ways that you can do that is through structured data. Another way you can do that is through like a history of collaboration, right? Like, so like Joel and I have been talking to each other for a while such that I know what Joel is talking about. Some like says a few words, then he actually means this, right? So really that frames the question as how can you bring people up to speed? And structure can enable people to get up to speed quicker. But then you can also say, okay, how can you connect people together who would naturally be up to speed such that they can communicate efficiently? Maybe Joel and I didn't know each other prior, but we've been thinking about similar things. Maybe a discourse graph tooling set could support like connecting the people, not just the knowledge.
So, Rob, I want to connect the dots between the research that you and Joel did to the graph for listeners that maybe missed the connection.
Well, I think one very important area is that the graph is mostly, at this point, like quantitative data that developers find useful to create their applications. This research in large part was about, okay, how can we start to add some more qualitative information onto the graph such that, it's able to call. I mean, like the graph has so much information, like someone could, if we were to build like an application like Geo that is able to take people's knowledge, but then also like reference statistics and tables and live queries from the graph. And that means like it can have some concrete evidence that's like verifiable as a part of it. Then another part of it is just that like these applications are popular right now. Knowledge graphs, personal knowledge graphs are popular. You see that in applications like Roam Research, like Obsidian, like Clarity, like Notion, any type like Agora. You see lots of these applications and they all have like little bits of different data structure. And one of the big ways that we can align this space is that we can try to figure out what's the interchange format and how can we just start indexing information from each of these individual applications into that interchange format. Then that can just provide massive gains for this space where people are able to like suddenly these apps are interoperable and they don't have this like they don't have this need to be locked into an application just because it has all of their data, right? Like if we can start indexing this information on the graph, then that means really these applications are competing on how do you give the user their best interface into this information? How do you like align with the user's play style, so to speak, for structuring their knowledge? So I just think that's going to be incredibly important. Like it's like this has been a goal for decades. Like the semantic web is an incredibly important set of ideas. But it's just like, okay, how can we get them into a format that gets on the graph that ultimately is going to be an interoperability layer that everyone can look to.
So Joel, is Web3 a tool for thought?
I would say in the normal sense of the word, probably not. Like I think like Web3 is more of a environment, and we kind of think of like tools for thought. It's like it's infrastructure to me, but that depends on how you interpret the word tool for thought. There's certainly tools for thought that are built on Web3 infrastructure that I can imagine, but to me they're different. Web3 is sort of like a different internet for me, and so to the extent that you think about the internet in terms of the overall infrastructure as a tool for thought, as opposed to a browser or a search engine as a tool for thought. That's how I think about that question, because to me, they're one-to-one. We're migrating versions of the internet from Web 2 to Web 3. It's like the underlying sort of pipes and wires that we're sitting on. So I think to me, what excites me about Web 3 is one of the interesting questions that you might not think to ask when you say, we're going to publish knowledge is where is it going to be stored? Who is going to have a say in what knowledge is? And I like the idea of thinking about this in terms of this decentralized storage, of the community of scientists and people who contribute to knowledge. They're the ones that store the knowledge. There's no like central authority that gets to decide this is what the canon is. We can define functions over the decentralized storage of like, the 100 people who research this topic. They all have their own little bits of knowledge, and there are multiple ways to combine them into a single canon, as opposed to vesting all authority into a single institution to say, this is how things are. These are all the facts. This is what we should believe. That's not how science works. And so to me, that's what's exciting about like better aligning the nature of knowledge production with the underlying infrastructure of there's no single canon that is true for all people for all time. Or we can compute functions over aggregations over the decentralized graph into a coherent whole that's useful for any particular situation. And to me, that's again where the graph comes in, because it's the API over the entire decentralized infrastructure to do useful things that are more than just peer-to-peer. Right? It's like all these 100 people give me the 50 coherent subgraphs and intersections between them to give me answers to the questions that I care about. That requires that you aggregate them in some way, right? There's some common language that they all speak. But that's what's exciting. That's currently laboriously done by individual editors who write literature reviews and synthesis. It takes a long time to do that. It's incomplete, and many systematic reviews are outdated very quickly after they're published, and people don't update them because they're too painful to do. That's to me a concrete application of like, if we had a way to query the decentralized knowledge graphs across all the people who work in the community, we can have living literature reviews, for example. Here's the state of play or states of play or different perspectives at any given time. If you are a policymaker, you could query the subgraphs across all the people who study virology and public health and synthesize that into a overall collection. Right now, it doesn't have to be static, right? And then in 3 months, when new things are learned, you can then compute a new function to then have a different picture. That's something that's hard for me to imagine in Web 2. So that's something that excites me about what's possible.
So, gentlemen, when you think about synthesis of thought and tools of thought and all these great themes we've been talking about here, what's the intended outcome? Is it more contribution to the synthesis that already exists? Is it to arrive at some point of knowledge or understanding? What's the intended outcome here?
Yeah, to me, it's all of the above. There's like different variations of. So I'll give you like concrete examples of what I want to see more of. From a outcomes perspective, one obvious one would be there's this wonderful quote from a researcher that I really admire. His name is Alan Newell, who's one of the founders of artificial intelligence. And he said, you can't play 20 questions with nature and win. That's not how science works. You got to synthesize. And to me, what I would like to see as the endpoint is more sustained conceptual progress in understanding the world, which requires that we synthesize instead of just continually running experiments and collecting data. That is hard to measure, but I could see that as in terms of like increasing rates of conceptual breakthroughs in theories that increase our understanding of the world. That's number one.
Literally, just like to point out here, literally just imagine you have 1,000 individual experiments going on and you only learn one lesson from each. And then imagine that you're able to synthesize all of those experiments, and then it becomes like a factorial, like you learn so much more if you're from the data, if you can synthesize.
Yeah, so science is one. And then the other one, to me, like to Rob's point, is strategy and solving problems in the world. Give you like concrete examples, right? Like, so right now, cybersecurity, misinformation, information security is a hard problem, in part because it cuts across so many different things, right? You need to understand human psychology, you need to understand communication, you need to understand the web infrastructure, you need to understand algorithms. My hope is if we're doing a better job at synthesis, especially across people's minds, we will start to see better solutions to move the needle on hard problems that are facing us as a society. To me, that's a very concrete outcome that I hope to see, where we'll start to get a better handle on these kind of wicked problems. Because think about one of the ways that I can think about it is, there's this idea of wicked problems and kind problems from Riddle and Weber, thinking about policy making as like a classic example of wicked problems, where one of the defining features is you don't get many tries, right? Once you make a move, you change the nature of the problem. So, in contrast to taking a test where you have 50 attempts, if you want to change something, you better have a good idea of what you're doing. And you can't just trial and error your way through it. You need to have some guiding theory that's reasonable. And to me, that's where the synthesis comes in. You have much better shots on goal because you have a better idea of what actually is going on, as opposed to just trying things out and seeing what happens. You don't get into that many tries with policy making. You don't get that many tries with big problems. So that's what I hope to see.
How about you, Rob?
We interviewed many builders of various tools for thought. And when we asked them, how do you expect your work to play into global synthesis? Their answer boiled down to, we're going to empower individual thinkers to synthesize better on their own and expect people to synthesize together out of band, outside of our application. That's not the problem we need to solve. I think that's important. I think that's valid, but I also think that there's a very big set of questions in how can people think better together? What sorts of processes? If you broke down what is synthesis and what's involved in that, there are people who, connect the dots. There are people who create the dots, and there are people who identify which dots are important. Maybe you could split that up into a decentralized system of many people cooperating under different sets of incentives to get to a shared goal.
Rob and Joel, I really appreciate your time and taking a minute here to explain your research, how it relates to the graph in Web3, some really important and exciting themes. And personally for me, I'm really interested in this type of thing because I really like to see innovation and I like to see humans advance in their knowledge and understanding of the world. So for listeners that want to stay in touch and follow some of your work, Joel, what's the best way for them to stay in touch with you?
My front door is Twitter. It's my first and last name, 86. Joel Chan 86 is the handle. And my website is joelchan.me if you want to read my work. So I post most of my papers there. You search me up on Google Scholar, you also be able to read more about me. But those would be the ways to get in touch with me. My DMs are open, so I get message requests, and that's my front door.
And how about for you, Rob?
Yeah, likewise, Twitter is my front door. My handle is just Robert Haisfield, first and last name. If you want to keep up with the research, we have a website. It's scalingsynthesis.com. If you go there, you will encounter a hypertext web of ideas, of questions, of claims about this space. And you can think about it kind of like a curated subgraph of just how you can build in this space and how you can build better towards creating synthesis, right? It's not going to be like you're used to reading research, which is probably as a document with a linear order top to bottom. This is much more about presenting you with the mess. We want to show you, okay, what questions were we asking? What claims did we come to realize? And what ideas came out of that? So I really think that builders, if they come to this site and they sense make over it, they don't just think about it like reading, but they think about okay, how can I follow the paths that are leading me towards building the correct solution to whatever problem I want to solve? I think that's what its purpose is for. It's also for people who like to use tools for thought themselves in order to come up with better processes for themselves. I think they'll accomplish the same goal. Again, if they read this as though it is a guided tour through the overall problem space and problem network that there is. So you can go to that website, you can read different pages on it, leave your comments. I will be keeping track of them and trying to respond to as many as I can see on a rate that makes sense. And then you can also reach out on Twitter at Robert Haisfield.
This has been a production of the GRTiQ podcast. For more information, including detailed show notes, visit grtiq.com/podcast. That's grtiq.com/podcast.
Please consider contributing to this project and helping build the community by subscribing and leaving a review.
GRTiQ
Podcast. Roger that.